Hi, this video is intended to help you start practice set 4 for Unit 1, the constant velocity model. It gives you a position versus time graph for a toy car and asks you to write the math model for the position versus time graph. The first thing I'm going to do is I'm going to determine the slope. I'm going to use this point right here and this point right here to help me determine that slope. This first point is at 0, 15, and the next point that I'm selecting is at 5, 0. So my slope, I'm going to say, is 0 minus 15 over 5 minus 0. So I get negative 15 over 5, which is equal to negative 3. My units for my slope are going to be my rise unit, which is meters, over my run unit, which is seconds. So that's how I calculate my slope to get started. Now, what I'm going to show you, though, is how that goes into my math model. Math model is always y equals mx plus b, so I'm going to write position equals m. So m is that slope that I just solved for. So I'm going to write negative 3 meters per second times the value, the unit on my x-axis, which is time, plus my y-intercept. My y-intercept for this graph is at 15, and the unit on that y-axis is meters. So there's my math model. Next up comes dirt. In order to figure out the dirt for this one, I'm going to instead put in a little text box because that seems smarter. The direction, my object is going in the negative direction. My initial position is 15 meters. My relative speed, I can't answer because I'm not comparing it to anything, but my type of motion is constant velocity, which I'm going to abbreviate CV. All right, next up it says, what is the change in position of the dune buggy from time 0 to time 10 seconds? How can I figure that out? There's different ways that you can solve this, but what I'm going to do is I'm going to look at my final position at time 10 seconds and then subtract my initial position at time 0. So my final position at time 10 seconds is negative 15. My initial position at time 0 is positive 15. So I'm going to say negative 15 minus 15, which is going to give me negative 30 meters. And that's how much it changed from time 0 to time 10. Next up, it's saying construct a quantitative motion map of the toy car's motion. So you've got a motion map right here. It only has the 0 shown. So I'm going to try to draw in equal increments 5, 10, and 15. And over here, negative 5, negative 10, and negative 15. They might not be perfect, but they're probably pretty close. And at time 0, I'm at position 15, so I'm going to draw a hollow circle. 1 second later, I moved 3 meters per second, or 3 meters, excuse me, to the left. So I'm going to draw a dot at position 12. Again, this is approximate. Another second later, it moved 3 meters, so I'm going to move it to 9, 6, position 6. I don't know why that keeps doing that. Position 3, position 0, position negative 3, negative 6, negative 9, negative 12, and then 15. I would connect these with arrows pointing to the left. I'm going to only do a few of them because I think you can understand what's going on next. Up next it says construct a corresponding velocity versus time graph of the toy's car. Well, the velocity of the car is equal to the slope of my position versus time graph. I calculated the slope to be negative 3, so I'm going to label these here. And I'm going to have a flat line, well, that's not super flat, a flat line at negative 3. Check. Now I want to write a math model for that. And I'm going to say velocity equals 0, because my slope is 0, meters per second, times time. And here is where you're going to write your y-intercept. Now your y-intercept is -3, so you can just do -3 or you can do plus -3. I'm just going to do minus 3 meters per second. And that is my math model for my velocity versus time graph. Up next is, using my velocity versus time graph only, calculate the change in position of the car from time 0 to time 10 seconds. I'm going to change my marker color. If I say that this is 2, 4, 6, 8, 10 seconds, what I'm going to do here is I'm going to kind of shade the area under between my axes line and my graph line. So between 0 meters per second and -3 meters per second for the first 10 seconds. And I'm going to calculate the area. Well, it's just a rectangle, so it's just base times height. So it's 10 seconds wide and -3 meters per second tall, and that gives me a value of -30 meters. If I want to, I can compare the answer for letter G to my answer for letter C up above, and you'll notice I get the same thing. That's not a coincidence. All right, lastly, it says use the math model to determine the time it would take for the car to reach a position of -48 meters. Show your work and include the appropriate units in your answer. I'm gonna kind of set the problem up for you, but I'm not gonna solve it. So -48 meters is my position that it's asking me about. -3 meters per second is the velocity I calculated way early on. Time is what I don't know. My y-intercept was 15 meters. So here's my setup. Now I just need to solve for time. You can probably imagine the units for time. Lastly, question I, it says use the math model to determine the position of the car after 39 seconds. Show your work and include an appropriate unit in your answer. So position equals -3 meters per second. But now instead of writing time, I'm going to plug in 39 seconds. And I'm still going to include my plus 15 meters. Again, on this one, I'm setting it up for you, but I'm not showing you the answer, and your answer should have an appropriate unit. Hopefully you found this helpful.